Close your eyes. Deep breath. Inhale. Hold your breath. Alrighty, students, we are right here, lesson 2.3. Remember to get a parental sign-off. We're dealing with properties of segments. So far, we've learned about the tilt of segments, which is slope, the middle of segments, midpoint, and then we've talked about the length of segments using distance. This lesson, we're going to talk about how to measure segments, add segments, and we're going to talk about something called the midpoint and bisector of segments. Measuring a segment. D is at -10 and F is at -3. J is at -1 and K is at 6. Ready? We're going to find the distance between D to F. And it's 7 units. Now, we're working on the negative side, but it's very important that even though we're working along the negative integer side of the number line, distance is always a positive concept. Distance is always a positive concept. So the distance of D to F is 7 units. Let's do J to K. You notice from J to K is also 7 units. So distance is always a positive concept. And in both of these, the distance is 7 units. Now watch very carefully the difference of my notations. We have DF, and then we have JK. If I want to say that the distance of DF is 7, notice what I use. I write DF with no segment above it. That means the distance between is 7 units. And JK, the distance between is 7 units. Now, since the measures are equal, we can say that equal distance. Then we can say that the segments themselves are congruent. That means physically the same length. And when I want to reference DF, the segment, I would write DF with a line and JK with a line. That's talking about the physical segments, not the numerical measurement. I can say DF, the segment, and JK, the segment, are congruent. It's important you understand the difference between these symbols. We use equal signs when we're talking about numbers, measures. We use a congruent sign when we're comparing a thing to a thing. Remember when I said geometry is more about the things? So keep that in mind. When you're comparing two things that are the same measure, you use what's called a congruent symbol. I'd like you to pause the video and find these distances. Pause the video, then restart. Alrighty, students, take a look. A to E is 14 units, B to C is 4 units, B to F is 13 units, and D to A is 12 units. Remember, distance is always positive, even if you're working on the negative integer side. Let's plot these points. So let's find these distances. S to T, of course, is 8 units. T to U, trace it with me, it's 5 units. You have 5 seconds to write down S to U. It's 13 units. So this is a very simple concept. When you have 3 collinear points, the distance between the smaller segments, so ST, the distance between, plus the distance of the other set of smaller segments equals the distance of the entire segment length. And notice, this is how we write it. There are no segments above because this notation all is talking about measurements. So you use an equal sign. So that means the distance between S to T plus the distance of T to U equals S to U. That's called segment addition. We're going to do this problem together. So remember, we read with 3 body parts 3 times, even though no one's watching. I want you to put your finger right where that yellow dot is and read out loud with your finger on the paper. Draw a segment with 3 collinear points, J, K, and L. Point K is between J and L. The distance JK is 2x. The distance KL is 5x minus 10. And the distance JL is 8x minus 18. Find everything possible. Now, let's highlight the key phrases, the fact that we have collinear points, and point K is between. Between does not mean middle, it just means between. We have 3 distances to label. And notice, I don't tell you what to find. You're going to see this icon more and more often, this little sponge thing. And that's my icon for saying, take this problem and squeeze out every drop of information possible. No longer am I always going to tell you what to find. You want to squeeze out everything that you can find. Ready? Let's go ahead and start drawing. We have 3 collinear points, K's between. So since K was not said to be in the middle, I offset it so I don't confuse myself. J to K, bracket, I'm going to color code. I recommend you do the same. Super important, folks. You talk about things before you talk about algebra. Things before algebra. So let me give you an example. The distance J to K plus the distance K to L adds up to the distance J to L. That's things before algebra. Things before algebra. Now, once you have your thing equation, you circle, plug, chug. Now you solve Super important. You never, ever stop at solving for x, because I don't tell you to stop at x. I say find everything possible. So we're going to go on and we're going to find the distance j to k, which is 2 times 8. And then we're going to find this distance right here, k to l. 5 times 8 is 40, minus 10 is 30. And we find our last distance, j to l. 8 times 8 is 64, minus 18. And you get 46. And you just check your work. Does 16 plus 30 equal 46? And the answer is yes. Now you have found everything possible. This page you do on your own. Pause the video. Welcome back. You should have set up a thing equation before algebra if you're following my instructions. Things before algebra. You solve for x. You should have gotten 5. Lovely. That's not the end of the problem. You plug it in. CA is 5, AT is 25, and yes, they add up to 30. Midpoint versus bisector. We're going to learn to draw midpoints. It says draw a segment HI with a midpoint of M. Also, point N is the midpoint of MI. One step at a time. We have a segment HI. It has a midpoint of M. Now, if M is the exact middle, there you have to put what are called hatch marks. These hatch marks tell me that H to M, the distance, the segment length, is congruent to M to I. That's what those hatch marks mean. Point N is the midpoint of NI, so here's MI, that means N is the midpoint this way. So I'm going to put little brackets over, and now I do double hatch marks to represent that N is a second midpoint, and that MN, the segment, is congruent to NI, the segment. Very, very, very important. If you don't have hatch marks, there's no hatch, there's no midpoint. Super important. If there's no hatch mark, there's no midpoint. A bisector, a midpoint, is exactly what it says. It's a singular point. Anything else that goes through the middle, a segment, a line, a ray, we call a bisector. So draw a segment HI, bisected by line YZ at point M. So that means YZ is cutting like a knife HI in half. Hatch marks. So we would say the line YZ is a bisector. Pause the video, do the work, then restart. Welcome back. We have JK being bisected by a ray ST at point Q. So bisected means it's going through a middle, so Q technically would have been the midpoint. S is an end point. It doesn't matter which side you start S at, but it's an end point going through Q, and your arrow point would have been T. Please correct your work. Now you want to review your work, rehearse what you've learned, please, either with a parent or yourself.